8.1, slope field and Euler's method. We're only going to do slope field. BC people, you need to study Euler's method yourself. Okay, so slope field has to do with differential equation, DE. Okay, differential equation means basically derivative. So let's say that you have dP over dt is equal to kt. So differential equation is just the same as derivative, but you'll see them most likely written in this way: dy dx, df dx, dp dt. So d something, that's a differential equation. And that's going to equal to something. Now, what happens is that this is going to be something that we can figure out the integral of. Now, this has to do with order. So what order means is the order of highest derivative. Okay, so what does that mean? For example, dy dx. dy dx is first order, meaning the first derivative. And then when you have something like this, d2 or d2y dx2 like this, it means second order because it's the second derivative. So they will refer to this a lot. They will say the order of the derivative is 2. That means they're talking about second derivative, and so on. Okay, so this lesson we are going to do slope field. Slope field means that we are going to sketch some slope field. So the important part is just write down this equation first and this initial condition. So y prime, meaning dy dx, is x plus y. Y prime is x plus y. And y of 0 is 1. The initial condition at x equals 0 is 1. They want you to sketch the slope field for the differential equation, then sketch a solution curve that passes through the given point. Okay, so I gave you guys some slope field lattice points. So, and then there's some in the back, so you can use some for the lesson today and then some for the homework, so you don't have to draw it yourself. Okay, so this means that somehow the slope is such that when you add x coordinate and the y coordinate together, you will get the slope. So in order to sketch this, what you want to do is kind of just like creating a table. Okay, so you want to create a table, and I'm going to put x here and y here. And then x, I'm going to start from -2 to 2. And for y, I'm going to do the same, -2 to 2. Okay, so I create a table with x and y value. What I want to do is figure out what the slope is at that point. Now, the question tells me the slope is such that I just add x and y together. So for example, at the point -2, -2, when x is -2, y is -2, what is the slope at that point? -4, because it tells me the slope at that point is x plus y. So it's just -4. Okay, what is the slope at -2, -1? -3. So my equation tells me I'm just going to add them together. Okay, do you guys think you can fill out the chart? Yes. Okay, go ahead and fill out the chart really quickly. We're going to graph this slope field. Okay, so did you guys all write down the values? Okay. All right, so this is -2, -1, 0, -1, -3, -2. No, I think I did this wrong. -3, -2, -1, 0, 1. -2, -1, 0, 1, 2. negative 1, 0, 1, 2, 3, and 0, 1, 2, 3, 4. All right, so what you want to do, so I'm going to tell you how to do this by hand, and then you are going to do this on the calculator. So negative 2 means at negative 2, which this is this point. At negative 2, the slope looks like negative 4. So think to yourself, how does negative 4 slope look like?
Pretty steep.
Pretty steep down, right? So then at negative 2, you're going to draw the slope like that. It's not perfect, just an approximate. Approximately negative 4, like kind of steep. All right, now let's look at, let's go down.
Negative 2?
Huh? Did I?
Positive.
Oh, yeah, you're right. Sorry. Negative 2. Thank you. Negative 2. Next, let's go down. So negative 1, negative 2. Negative 1, negative 2. So x is negative 1, y is negative 2. It looks like negative 3. So a little bit less steep. Okay, this is all approximate, and it doesn't have to be perfect, okay? So don't go crazy trying to make it negative 3. 0, negative 2. 0, negative 2 is here. So at this point, it's around negative 2. So a little less steep. Oh, maybe not that less steep. Okay, again, please don't try to be perfect. 1, negative 2. It looks like negative 1. And then 2, negative 2 looks like 0. 0 is easy to draw, just horizontal line. All right, and then you do the same thing for everything. So at negative 2, negative 1 looks like negative 3 again. So negative 2, negative 1 looks like negative 3, something like that. And then negative 2, negative 1, 0, 1. Okay, again, don't be perfect. There is no point to be perfect. Okay, so go ahead and draw the whole slope field. Okay, please don't try to be perfect. Just kind of draw it as long as one looks a little bit slightly steeper or slightly, I don't know, higher than the other one, and you're fine. The reason we're only doing this for one day is because I don't want you to take too long graphing this. It's not a very big topic. You should have your graph looking like this, and they have an initial condition. Initial condition is y of 0 is 1. That means x, when x is 0, y is 1, right? That's what the initial condition means. Therefore, at x equals 0, y is 1. That is where you're going to start. And then what you're going to do is you're going to follow the slope field. The slope field says you're going to turn this way and this way. So this is how the graph will look like. You're kind of trying to just think this is like water flowing or wind flowing. You're trying to go with the flow. You start from this point. Where do you think that, pebble or something is going to go next? Where do you think it's going to go next? So then you kind of go according to the slope. Okay, I'm going to tell you how to graph this on your calculator. So what you're going to do is in y1, so now that everybody has the program, you're going to go to y1, and then you're going to type in the slope field, the slope, x plus y. X is where it usually is. You can go to y1 and graph. X is where it usually is, and a plus. To go to y, you have to type in the letter y, which is click on alpha. And then on top of 1, the green button says y. So it's x plus 1. Okay, you have to type in x plus 1.
What?
Yeah, x plus
Okay,
y.
y equals,
X plus y. Plus y. Okay, show your tables. Someone knows how you to do it. No. It's not what it's wrong.
okay, y equals x plus
X
1.
plus y. No, I said to put it in. Okay, so everyone has to type in x plus y. Please make sure the people around you have it. And then what you want to do is you want to run the program I just sent you. So go to program. I sent you 2 programs. One is Riemann sum because a lot of times you do it for homework and then I know it takes you a long time to calculate. If you click on the program for Riemann sum, you can look at it later. It has right hand, left hand, midpoint, trapezoid, so then it makes the calculation a lot easier. Okay, anyways, you're going to go to slope F. That's slope field. And then enter. It's going to graph the entire slope field. So like that. Enter. Enter again. All right, so this is the slope field. You guys see it? It's the same as the one you graphed by hand.
No, it's not.
It's the same. It's the same. It's just that you're not in the same window. You have to go to the same. All right, that's that. Okay, so let's go on and try to solve another problem. This one's going to take too long. Let's try this one. Given the differential equation y prime equals negative x over y, sketch the slope field for the differential equation and then sketch the solution that passes through the origin. Oh, I'm sorry. Just sketch a solution curve. Okay, this one's, the origin is undefined. Y prime equals negative x over y. So write out your tables and then sketch it out. You can also start from, graphing it to see how it should look like and then match it with your actual graphing. Okay, but anyways, graph it. Okay, so you can check with your calculator, but the slope field kind of looks like this. Okay, so something like that. Now, if you want to just draw a solution curve, what do you think the solution curve is going to look like?
Out of where?
Just a solution curve, a curve that goes through the slope field. How would that look like? Not a trick question. If you draw a curve through this field, what direction do you think it's going to turn? Like what kind of shape would it look like? Yes, thank you. A circle, right? It's just going to look like a circle. Now, we're going to learn how to figure out the actual equation tomorrow, but it's going to look like a circle. And hopefully when you graph it on your calculator, you do see a circle as well. All right, next one. We're going to go backwards. I'm going to give you a slope field. You're going to guess which differential equation it came from. All right, here it is. Talk to your partner, A, B, C, D. Which one? What's a good way to guess? Maybe pick a point, look at the slope, and then try it and see if you get that. You may want to pick the one that's a 0. Like horizontal line is a slope of 0, right? So then you may want to go to a 0 slope. So this is 1, 1. 1, 1 is supposed to give you 0. Check to see which is going to give you 0. right? 1, 1 is supposed to give you 0, so not A, not D. So you have to decide between B or C. B or C. Okay, you also may want to check something like this. This is a 1 slope, right? So at 2, 1, it's going to give you positive 1. So which one is going to give you positive 1? B or C? Huh? B. Yeah, so the answer is B. Okay, so this is how you check. Given a slope field, how do you check which one is the correct one? All right, try another one.
Are we going to be asked to graph a slope field?
Yes.
Or
Yes.
to know like which equation?
Both.
It is?
Both.
On A, B?
Yes. Okay, next one. Guess which slope it came from, which differential equation it came from. Again, you want to check the special points. The 0 slope, or see like all the slopes are positive. What does that mean? And you can see that all the slopes are the same, right? Vertically. If all the slopes are same vertically, that means y doesn't matter. No matter how much I go up in y, it's not going to affect my slope. So y doesn't matter, which means there's probably no y in the answer, in the differential equation.
So there can be no y in the answer.
Yeah. What do you guys think the answer is? The only one without a y. Yes. Okay, so that's it. All right, just a reminder, BC people, you need to read Euler's method on your own.